Hey everyone, and welcome. Today, we're going to strap in for a cosmic field trip, a high-speed tour of our very own solar system. So, let's fire up the engines and get this cosmic road trip started. So, are you ready? Because we're about to visit every planet, get a handle on the forces that govern their celestial dance, and maybe even settle a famous planetary debate along the way. All right, let's dive in. And here it is, our destination. Right at the heart of everything is our star, the sun. It's the anchor, the engine, the undisputed ruler of this whole system. I mean, everything you see here, it's all held in this incredible cosmic dance by the sun's massive gravity. So where do we even begin? Well, it only makes sense to start with the star of the show, literally. So, just how big is the sun? Well, to wrap your head around it, try this. Imagine you could just line up Earths, one after another. You need more than 100 of them, side by side, just to stretch across the face of the sun. It is just mind-bogglingly huge. So, what is it really? Well, at its core, the sun is just this enormous ball of super hot, glowing gas. It's basically the giant furnace of our solar system, pumping out all the heat and light that makes life on our own little planet possible. It's, by far, the most important thing in our sky. Okay, let's blast off from the sun and head into the inner solar system. Let's go meet our closest neighbors, the four small rocky planets. And here they are, the inner crew. First up, you've got the heavily cratered Mercury. Then there's Venus, which is always hiding under this thick, scorching blanket of yellow clouds. Next, of course, is our home, the beautiful blue and green marble we call Earth. And last but not least, the rusty, dusty world of Mars, the one and only red planet. Okay, hold on. Before we zip off to the outer planets, let's hang out on Earth for a sec. I mean, we see it every single day, right? But have you ever stopped to think about what's really going on when day turns into night? Well, the answer is actually pretty simple, and this little demonstration explains it perfectly. Think of it this way. Imagine you are the Earth and a flashlight is the sun. The part of you facing the flashlight, that's daytime. Now, if you slowly spin around, your front is now in the dark. And boom. That's nighttime. It really is that straightforward. And you know, that spinning motion has a special name. It's called rotation. Our planet is always constantly spinning or rotating on this invisible line called an axis. And one full spin, yep, that's what gives us one full 24-hour day and night. All right, tour's back on. Buckle up, because we're leaving the cozy inner planets behind. We're going to cross this huge field of space rocks, that's the asteroid belt, to go meet the real heavyweights of the solar system. Okay, so I want you to picture those four rocky planets we just visited. Got them in your head? Mercury, Venus, Earth, and Mars. Good, because what I'm about to tell you is going to blow your mind. It turns out they are just tiny compared to these guys. Wow. This image just says it all, doesn't it? Those huge planets in the middle, those are the gas giants. Now, look way down at the bottom. See those little specks? Yeah, that's us. That's Earth and its neighbors. The difference in size it's just staggering. If that last image wasn't enough, this fruit analogy really brings it home. So if Jupiter was a big watermelon, then Earth, we'd be a little cherry tomato. Mars would be a blueberry, and tiny little Mercury, just a single peppercorn. It's kind of humbling, right? It's just a fantastic way to feel how massive these differences really are. So, okay, we've met the whole planetary family now, all 8 of them. But it begs the question, right? What keeps this whole incredible dance going? What's the invisible force that's pulling all the strings? I mean, think about it. You've got all these massive planets zipping around at incredible speeds. Why don't they just fly off into deep space? What's keeping them all in line? The answer is an invisible force called gravity. A great way to think about it is with magnets. You know how you can feel that pull between two magnets, even when they're not touching? Gravity is kind of like that. Now, to be clear, it's not the same thing as magnetism, but that idea of an invisible force, a pull, that's exactly what gravity is. And it's the force that runs the entire show. And you know what? The main rule for gravity is actually super simple. It all comes down to one thing: mass. The more stuff an object has, the more massive it is, the stronger its gravity. And that's why the sun is the ultimate boss. It has more than 99% of all the mass in the entire solar system. So naturally, everything orbits around it. All right, for the last stop on our tour, we're heading way out to the cold, dark edges of the solar system because it's time we finally settled that age-old question: what's the deal with Pluto? You know, for most of the 20th century, we all learned in school that there were 9 planets. Simple as that. Pluto was found way back in 1930, and here's a great piece of trivia. It was actually named by an 11-year-old girl from England. How cool is that? But then, as our telescopes got better and better, we started finding more and more objects out in Pluto's neighborhood. And then we found one that was even bigger than Pluto. So astronomers had a bit of a crisis on their hands, which led to a huge historic meeting in 2006. So basically, the world's astronomers got together and said, okay, we need an official definition for what a planet is. And they came up with 3 rules, a kind of planetary checklist. Rule number 1, it has to orbit the sun. Pluto does that? No problem. Check. Rule number 2, it has to have enough mass, enough gravity to pull itself into a nearly round shape. Pluto's a sphere, so check. But then we get to rule number 3, and this is the deal breaker. A planet has to be the gravitational king of its own orbit. It has to have cleared its neighborhood of other big objects. And Pluto, well, it doesn't do that. Its orbit is full of other icy rocks and debris, so that's a fail. So, since it only passed 2 out of the 3 tests, Pluto was moved into a whole new category, the dwarf planet. And hey, it's not some kind of demotion. It's actually in good company. It shares this classification with a bunch of other cool worlds out there, like Eris, Haumea, and Makemake. So it's not like Pluto got kicked out of the club. It became the founding member of a brand new, super interesting one. And that's a wrap on our tour of the solar system. We've said hi to our star, we've flown by the rocky inner planets and the giant outer worlds, and we've gotten a handle on the invisible force that holds it all together. But as we finish up, looking out past Neptune, into that dark, cold region where Pluto and its friends live, it just makes you wonder, doesn't it? What other amazing discoveries are just waiting out there in the dark for us to find?